This is Ms. Santos, and for this session, we're going to be talking about Arrhenius Theory. Arrhenius Theory can help you distinguish between an acid and a base, and it does this by letting you know that an acid is a substance that produces a hydronium ion, or, and I added this here, a hydrogen ion in an aqueous solution. A base, on the other hand, is a substance that produces hydroxide ions in an aqueous solution. Down here is an example of how hydronium is created. A hydrogen ion reacts immediately with a water molecule to give a hydronium ion. Taking a deeper look, here we have HCl. When we put HCl in water, it dissociates, which means to break down, and it gives you a hydrogen ion and a chlorine ion. In an acid solution, that contains only a hydrogen ion as a positive ion. So that's what this is right here. And when you're looking at Regents questions, sometimes they'll ask you which of these would contain, so the questions would admit acid and just say which of these would contain only a hydrogen ion as its only positive ion. So you would have to know that it's an Arrhenius base. An Arrhenius acid. And you would know by looking at what's in the substance, and it's usually when it has an H in front of it. Another example would be H2SO4. As you can see, there's a hydrogen. There is two hydrogens though, but the fact that it has a hydrogen in front of it would make it an acid. There is a way where if you go to your periodic tables, you can check on, there's actually a table that shows you and lists all the acids. Here you go. So this would be table K. And table K will list you all the acids. And if you notice, you'll see they all start with hydrogen. HCl, HNO2, HNO3, H2SO3. So that means you get 2 hydrogen ions here. This one will get 3 hydrogen ions. The only one that's a little different will be this one right here, so acetic acid. And acetic acid can have either the hydrogen at the end of it or the hydrogen at the beginning of it. So this one is a little confusing because sometimes we just see this OH here and automatically assume, oh, it's not an acid, it's a base. And that leads us to talking about Arrhenius bases. So we're going to go straight to this one. Arrhenius bases pretty much is what we mentioned earlier. It has hydroxide ions. And here's one example of base, NaOH, and it ends in OH. NaOH breaks apart and it produces a sodium ion and a hydroxide ion, or calcium hydroxide, which breaks apart and gives you calcium and 2 hydroxide ions. And if you had to figure out from a whole bunch of examples which would be a base, here's another. We'll go on the reference table, and it's never going to be limited to just these, so we'll have more. They end in OH. This is the only one where it doesn't end in OH. And when you see something like this, just remember that even though it ends in OH, this substance here, when it breaks apart, it just gives you, or when it disassociates, it's not going to give you an OH ion. Instead, it's just going to give you a hydrogen ion. So pretty much a dissociation of acetic acid would mean that it releases a hydrogen ion rather than a hydroxide ion. And here's another example. So when bases dissolve in water, the ions separate. And again, it's Na and then OH. Those are my ions. And this goes back to the previous lesson that you guys saw, where we talked about dissociation. And one of the important things that kind of helps with dissociation is if you go to your reference table, and I feel like I've mentioned this to a few of you guys when you asked for help. and it's knowing the polyatomic ions. And for this level of chemistry, you don't have them memorized, but if you guys recall from class, we remember that it's actually on the reference table. And if you guys go to, and I'm slowly scrolling up, I'm sorry about that. Let's see here. There we go. Table E. You're going to notice that these are our common ions right here. And these are the ones that will break apart or disassociate when we have a solution. So these will be combined with hydrogen. So if you guys look at, I think we were looking at acetic acid, and acetic acid, it's not here. I'm trying to see. Well, we have acetic acid in the other table, but we have acetate, and acetic acid is what we have when we have acetate and then the additional hydrogen. So if you guys see 8CH3COO, that combined with a hydrogen is what gives you acetic acid. So it was one of the ones we were looking at. So just remember that you can break them apart in that manner. So that's really it for this session. If you guys have any questions, feel free to reach out to me on Google Hangouts and I can help you out. And I hope you guys have a great day and this video was helpful.